thyristor, explained. Thyristors are semiconductor devices with 3 leads. A small current at one lead will allow a much larger current to flow through the other 2 leads. The controlled current is either on or off. Therefore, thyristors do not amplify fluctuating signals like transistors do. Instead, they are solid-state switches. There are 2 families of thyristors, silicon-controlled rectifiers and Triacs. SCR switches direct current and Triac switches alternating current. This is the visual representation of the small current and large current. Silicon-controlled rectifiers. The SCR is similar to a bipolar transistor with a 4th layer and therefore 3 PN junctions. It is sometimes called a 4-layer PN-PN diode since it passes a current in only one direction. SCR operation. If the anode of an SCR is made more positive than the cathode, the 2 outermost PN junctions are forward biased. The middle PN junctions, however, is reversed biased and current cannot flow. A small gate current forward biases the middle PN junction and allows a much larger current to flow through the device. The SCR stays on even if the gate current is removed until power is disconnected. Kinds of SCR. SCR are categorized according to the current they can switch. Here are 3 general categories. Low current. Low current SCR include those that switch up to 1 ampere at up to 100 volts. Medium current. These SCRs switch up to 10 amperes at up to several hundred volts. One common use is solid-state switching for auto engines. High current. These SCR can switch up to 2,500 amperes at up to several thousand volts. They control motors, lights, appliances, etc. This is the SCR symbol. How SCR are used. This arrangement shows how an SCR is used to switch on an incandescent lamp. Other devices can also be controlled using this. Triacs. The Triac is equivalent to 2 SCR connected in parallel. This means Triacs can switch both direct and alternating current. Notice that the Triac has 5 layers plus an extra N-type region. Also, note how all 3 leads make contact with 2 layers. Triac operation. The 2 parallel SCR that form a Triac face in opposite directions, reverse parallel. When used to switch alternating current, the Triac stays on only when the gate receives current. Remove the gate current and it switches off when the AC passes through 0 volts. Kinds of Triacs. Triacs, like SCR, are categorized according to the current they can switch. Triacs don't have the very high power capability of high current SCR. There are 2 categories. The low current and medium current. Low current Triacs switch up to 1 ampere at up to several hundred volts. Other case styles also used. Medium current Triacs switch up to 40 amperes at up to 1000 volts. Many case styles are available. Triac symbol. Remember, the Triac is the same as 2 reverse parallel SCR. How Triacs are used. This arrangement shows how a Triac can switch on a lamp powered by household line current. Motors and other devices can also be controlled. 2-lead thyristors. An SCR or Triac will switch on without a gate signal if the voltage across its other 2 leads reaches a certain level, the breakdown voltage. This self-switching ability makes possible 2-lead thyristors. 4-layer diode. A 4-layer diode is an SCR without a gate. It switches DC voltage. While the Diac is a 3-layer device similar to a PNP junction transistor without a base lead, it switches AC voltage. Thank you for watching. If you liked this video, kindly leave a thumbs up, and if you haven't subscribed yet, just click the subscribe button and hit the notification bell for more videos.